everyone, welcome to the fourth and final webinar in the training series. I'm Andrea, thanks for joining us. In this webinar, we'll cover some of the remaining features of Hazelcast, such as transactions, as well as enterprise features such as WAN replication. David will also give a sneak peek at the Hazelcast Roadmap for 2014. David Brimley, our panelist today, is Senior Solutions Architect for Hazelcast. David has extensive knowledge of distributed caching products, having worked with Coherence, Gemfire, and Hazelcast for the past 6 years. He's been in the IT industry for 25 years, and his last 16 years he spent in investment banking in London. We'll have a Q&A period after David presents. You can ask questions using the question box in the GoToWebinar control panel. And I'll turn it over to David now.
Okay, great. Thanks, Andrea. So today we're going to be rolling through a whole bunch of features that we get to cover in our other previous webinars. I'll just go straight to the agenda. So today we're going to be looking at topics. So PubSub, that's a nice way of distributing messages around a cluster, and you can also message in and out of clients as well, in and out of the cluster. Transactions as well, we'll look at the transaction features of Hazelcast. We'll also look at WAN replication. So WAN replication, very important if you have clusters around the world or in different geographical locations, or even if you want some kind of DR solution, WAN replication is the feature that you use for that. We'll take a brief look at the C# client very, very briefly, and then we'll look at the Hazelcast roadmap for the next few versions that are coming up in 2014 and 2015. So moving along, topics. This is quite a unique feature for Hazelcast in terms of in-memory data features. It's essentially a PubSub topic system, so it's exactly the same as you would find in any other service of a similar nature. As I mentioned, it's a cluster-wide publish and subscribe mechanism. You can configure topics via XML or programmatically. When you do actually publish to a topic, it's an asynchronous publishing, and there are a number of things you need to think about when you're actually configuring a topic as well. So you need to think about ordering, which by default is false. So global ordering. So when listeners receive topics, by default it is false. So let's say you have 3 or 4 clients that are listening to a topic. Someone publishes. The order in which things arrive from other consumers could be in a different order if there are multiple publishers, that is. So if you want to ensure that ordering is always strictly enforced, then there's a global ordering parameter you can set. We also have statistics on the topic as well. One thing to bear in mind as well, also when you're using topics in Hazelcast, is that the topic is distributed over and consumed over something called the event queue. So the event queue is used by other systems as well, other parts of Hazelcast. So there are things you need to consider if you're a heavy user of topics, and also at the same time you're doing other things. So as I mentioned, the event queue configuration, you'll find that in the majority of cases the default configuration is okay for you. But if you're scaling out topics and you find you're hitting bottlenecks in certain places, then the first place to look at is in these Hazelcast event queue properties. So here you can see you can assign more threads to the event queues. So just something to bear in mind if you're looking to heavily scale out topics in Hazelcast. So let's dive straight into a sample. So hopefully, if you've been following our webinars previously, you'd have already downloaded the Hazelcast Code Samples project. If you haven't, let me just show that to you where you can download that from. It's available on GitHub, as is our source code. We're an open source product, Apache 2 license, so you can get all of our source code for the Hazelcast here. But we also have the Hazelcast code samples, which we're basing a lot of these webinars on. And you can download these here, and this Hazelcast code samples is a really good resource of code samples that gives you a good grounding in all of our Hazelcast features. So there we go, there's the distributed topic and the basic PubSub sample that we're going to be going through. So I've already got these downloaded in my IntelliJ. So let's look at those now. So where we're looking at here is the distributed topic module, and we can look at the basic pub sub example. So let me just close all of these guys here, and let's look at how this works. Let's go into presentation mode as well, so it makes it easy for you guys to see. So incredibly simple topics, incredibly simple. You just use a Hazelcast instance reference, and you grab a topic, and you give that topic a name. It's that simple. You see that you can provide a generic as well for the actual topic. That's the object that's being published. So that can be any object you like, as long as it's serializable, of course, because this is a distributed system. And what you can see here is we're just doing a topic.publish, okay, and we're just publishing a date into a topic called topic. And then on the other side of the pub sub mechanism, you'll find, if we look at the subscribed member, the subscribed member is just listening on that topic. So we're getting the topic, and we're just registering, we're adding a message listener to that topic. So it's a callback effectively that we get with the message. And then you'll see that we can actually grab out the message object. Because it's stamped with a generic, we know that that's a date. Okay, so this is a very, very simple example, but it gives you an idea of just how quickly you can get set up and running with topics in your system. And as I mentioned, a topic, because a topic is available off of the Hazelcast instance, you can have this, you can consume topic messages from Hazelcast clients or from Hazelcast servers. So let's run this then. Let's fire up the subscribe member. These are both running as cluster members. So let's run that up. Here we go. And because you'll notice we're just using the default, so this will be using Hazelcast-default XML. And we're subscribed. So let's now run the publisher. And we should simply see a data bit on the subscribe side. It's just firing up now the publisher member. That will join a cluster. Here we go, we'll join the cluster now, and we're publishing. And if we go over here, there we can see there's the data that we published to the other side. So what I can do as well is just to prove that this is a real pub sub, is let's add some more subscribed members, and we'll run another publisher, and you'll see that we should get the message if we rerun this program here, the publisher. So we'll just wait for this to join that. You can see that's successfully joined and resubscribed. So let's just restart the publisher. And that should join the cluster. Here we go, it's rejoined, and it should have resent. And there you go, that's received the message there at 1708. And if we go down here, and there's the same message, 1708:59. So you can have, you can see there that you can have many subscribers to a message, and as I said, they can be clients or they can be cluster members. So let's move along, and we'll go back to our presentation. Oh, it's not that one. Just bear with me. If I can find it. There we go. So, very quick introduction to topics. Very simple subject, but very powerful. So, Hazelcast Transactions. Transaction support in Hazelcast takes on has a number of features. You can run transactions on the first bullet point there. You can see in terms of our distributed data structures that can be included within a transaction. You've got the queues, maps, sets, lists, multi-maps. So they're all of the data structures that you can mutate and that can take part inside a Hazelcast transaction. You noticed actually that we've been talking about topics, but you notice topics are not included in transaction functionality. We have two ways of running a transaction. So there's local, you can have local transactions, and there's two-phase commit transactions as well. So two-phase is the default, and we'll look at the differences between local and two-phase in a moment. The isolation level is on reads is repeatable read. So what we mean by that is if within a transaction you read something out of a queue or a map at the start of the transaction, and you to read again further down in the transaction that same key or that same item out of the collection, you're always guaranteed to get the same value. So whilst you're running your transaction, if there's another thread or another user or another process somewhere else that's updating that same item, you're not going to read that. You're not going to read that value. So it's a repeatable read isolation level. In terms of what transactions can work with, we've got our standard Hazelcast transactions that can work as we just described. You can have these transactions run inside J and take part as a J2ee container transaction, so available via JNDI, and you can have that available via the JCA adapter, and we'll briefly look at how you can configure that. There's fledgling support for XA as well, so Hazelcast can take part in XA transactions, so you can enlist Hazelcast as a resource in an XA transaction. And importantly, and this is quite a powerful feature of Hazelcast, Hazelcast clients can take part in transactions as well. So there are quite a few memory data with products that don't actually support that, but Hazelcast is one of the ones that does. So let's just talk about local and two-phase commit transactions, because there's depending on which vendor you choose, some will talk about local transactions and two-phase commit transactions, but please do look into exactly what they mean by that, because not all vendors implement their two-phase and local transactionality in the same way. With Hazelcast, what we mean with a local transaction, it's a cluster-wide transaction. So it's really, I guess you could effectively call it's a standard two-phase transaction. But we call that a local transaction. So all of the members in the cluster take part in the prepare phase of the transaction, and all members take part in the commit. The only thing you need to be aware of is that if there is a member failure on commit, that may leave your cluster inconsistent, because we don't pass around the full transaction logs to every single member. So you get this guarantee of cluster-wide transactionality. But with the local transaction, you get that potential problem with commit on member failure. So that's something just to bear in mind. So our two-phase transactionality, again, it's cluster-wide, but it's enhanced two-phase. So again, it's the same as what we're calling our local transactionality. All members take part in the prepare, all members take part in the commit, but the main difference here is that all members have a full cluster log of the changes. So if any single member fails that is taking part in the transaction, it fails during the commit phase, you know that the commit log will still roll through, because we have a backup. Every member has that commit log. Okay, so it will always go through. So transaction configuration. There are three things we need to think about when we configure our transaction. So the last one, the bullet point said, which we've already looked at, is the transaction type. So that's local or two-phase, and as we know, two-phase is our default. So we give you the maximum protection as default. Durability. So that's the backup count for the transaction logs. So by default, that's 1. Okay. So you can change that. And then also there's the timeout, which is the lock hold time. So by default, that's 2 minutes. Now, the lock hold time, what we mean by that is if you're in a transaction and you read a map entry or a map with a key, then we will lock that that read for a default of 2 minutes. But you can change. Well, we will wait. You actually wait for that lock. Sorry for that time, and the default of that is 2 minutes. So let's go into transactions. And let's look at a code sample here in the lab. So here's Hazelcast code samples again, and we're going into transactions and transactions basics. And really what we're just going to be doing here in this lab is we're just looking at the code that you need to write to perform a transaction on some kind of mutation operations. So let's come out of this view and we'll go into our examples topics, and here's transactions. Okay, and we'll look at transactions basics, and we'll just look at transactional member. And I just really want to talk you through, I'm going to kill all these other things we've got running here, and we can talk through, let's talk through the actual code itself. So you can see here, here's we're using the Hazelcast instance again. So if you were to run this class, you would create a cluster member. And then what we're doing is we're creating this transactions options object. And here you can see we're setting the timeout. So remember that was the lock wait timeout. The transaction type, which you don't have to set because here we're using 2-phase and that's the default. But if you wanted to change that, this is where you would do it. So you could change that to local here. So that would be the local start of transaction, and then you've got the durability. And remember, the durability is the number of backups for the transaction log. Okay, that we have. Now, once you have your transaction options, and by the way, you don't need to pass this if you don't want to. It will use a default, but you create off of the Hazelcast instance, you create a transaction context. Okay. And once we have a transaction context, you then begin your transaction, and then via that transaction context is where you get references to any of the data structures within Hazelcast that you want to mutate or take part in the transaction. So ordinarily, if you were not using transactions, you would just do an hz.getMap or an hz.getQ. But in this instance, we want to get a transactional reference to it. So we're doing transaction context getMap here, okay? And you can see this actually returns a new interface called transactional map. And then you would just work with your structures as normal then. So we were doing map puts here, and then you just perform a commit, or you can roll back on any kind of failure. So any kind of problem with the commit, that would throw up an exception here, and you can catch that and you can roll back your transaction. So it's a fairly familiar way of dealing with transactions. If you dealt with transaction frameworks before, it'll be very familiar with how you work with that. And then you can handle you could have some multi maps in here in the same transaction that you're working with, or several maps, and they would all work within the one transaction. So you're completely free to use as many data structures as you wish within the transaction, and they will all take part in that. So let's come out of this, and we'll go back to our slides. So J2ee Transactions, as I mentioned, you can have Hazelcast take part in transactions inside a J2ee container. So we do that via our JCA adapter. If you download Hazelcast, you'll find the Hazelcast JCA jar. So just deploy that into your EAR file. So here it would be Hazelcast-JCA whatever version you're running. And if you go to our documentation website, you'll see examples for how you would use that within JBoss and Glassfish. Here's an example here I've shown you of exposing the connection factory as a JNDI reference via this is via Glassfish within the web XML. So here you can see we're giving you the connection factory for the JCA resource, and it would be exposed as this Hazelcast CF. Now, if you want more information and to look at the examples of that, we have some really good documentation now coming in 3.3. I'll just find that for you. And if we go to this, here we go, underneath transactions, you can see there's a whole chapter on J2ee integration, and actually here's an example of looking up, doing a context lookup on a JavaX context lookup for a transaction resource, and here it is here. And there's your Hazelcast connection factory. You can get a connection then, and then via that connection here, then you can actually get your hands on the transactional map, and from that point on, it works exactly the same way as the code samples that we've looked at before. But there are just some examples here of Glassfish, and there's some JBoss examples here of various J2ee containers and how you can include those and configure those with the in this case there's JBoss and the module XML file that you would have to amend. So as I mentioned, we're just introducing XA support for transaction analysis as well. It works in a very similar way to standard transactions. You can see here in this code example I'm showing you here, you get your transaction context off of the Hazelcast instance. As I mentioned before, you return a transaction context. And then you grab an XA resource off of that transaction context, and then within that, then you can enlist the Hazelcast XA transaction context. You can enlist that into your transaction. Okay, so here you can see the transaction in this resource, and then what you would do then is if you have any other resources that you want to take part in the transaction, such as a database or anything else, you would then enlist those resources here as well within the transaction. So with one or two coded, you can start taking part in XA transactions. And I believe this if you look at this example, there's again, if we go down here onto the documentation website, you can see here's this example here, and this actually, I think this is an Atomicus transaction example. So moving on. I want to look at the next topic, which is WAN replication. So WAN replication, as I mentioned, there'll be a number of reasons why you want to enable WAN replication. WAN replication is a way of having communicating between two distinct clusters. Okay, so imagine a scenario where you have two data centers, and one's in let's say London, and another data center is outside of London, maybe for DR purposes, disaster recovery. But you want to keep those two distinct clusters in sync. Okay, so all of your updates are going to London. You're going to want those to go into your DR site, and that DR site is available. It's a warm DR site, and that cluster's running, and you want that available and to be in sync with its data. If in the DR scenario you need to switch over to that off-site data center. So that's why you'd use WAN replication in that instance. And it's basically TCP/IP connection between two clusters and data flying either both ways or one way. So by that we mean it's an active-active connection or it's an active-passive connection. Another way would be to provide many local points of presence to your business around the world. So if you had business locations in, let's say, New York, London, and Tokyo, and you had users in all of those regions, and they were reading and writing from your cache and doing various operations on that were reliant on Hazelcast, it might make sense to have Hazelcast clusters in each of those regions to provide, speed and good service to your users. But then you might have users in New York that are writing records that you want your London users to see. So in that case, you would then connect them up via WAN replication. So let's just talk a bit more about that. I have a presentation here we can use. So WAN replication, we provide that out of the box, as I mentioned, you can configure WAN replication to be active-active, which means that you can connect between two clusters and data can go in both directions. So an update in either side will be replicated over to the other side, or you can have an active-passive setup where you update data. Let's say in the example of our DR situation, you update in your main site, and then the data only flows one way, and that would be an example of an active-passive set of replication. Configurable via XML API Spring, and this is common throughout most all of our components within Hazelcast. The configuration is those three things. If you want to, there's something we have called the WAN Replication Publisher, which is our default implementation of WAN replication. If you wanted to extend that, then you can implement filtering and routing. We provide a form of overflow as well, where we overflow events to a queue that you can configure, and we'll briefly look at that configuration. But one of the main benefits of the WAN replication is that it can survive outages in other sites. So take an example where you have London and New York replicating with each other. If the New York system went down, let's say for an upgrade or something else, the socket was disconnected, any updates into London will be stored up until New York comes back online, and then those updates will flow through, and we'll do a brief demonstration of that in a moment. And the last but not least, the way that you can configure Hazelcast with replication is that you can, if you wish, only certain maps would replicate, and other maps would not replicate. And you're entirely there's an entirely flexible way of configuring maps to replication schemes. So you can have many different endpoints for different types of maps. So you can mix and match your replication schemes and your endpoints to different types of maps. So let's move on. Let's just move down to the next slide. So one thing as well that you may run into is potential collisions of keys. Okay, so that would be a scenario where in London and New York you have two different users. They both update the key, the same key, exactly the same time, and those records then come across to the other sides. They're opposite clusters. And then, of course, you've got some kind of collision there because you've got the user update version 7 of a record in New York and the user in London that's updated version 7 of the same record, but they've changed potentially different parts of that record. This version 7 will come across, but the receiving side will already have noticed that, hold on a minute, it'll say, I've already had an update for that version, and this is where then merge policies come along. You can define merge policies where you get, you can see here from the actual the interface definition here that you're given the merging entry, so the entry view, the map entry view, an existing entry, and you can code some kind of resolution within that. You can look at the two values and you can decide what happens to that. Okay, so what you return out of that is the final value of the entry. Okay. So map merge and collision detection is quite important in WAN replication scenarios. So we have a number of out-of-the-box collision detection policies. So here's a few here. There's pass-through, which just passes through, and then there are different ones that have to do with high hits or latest update map merge policies. But as I mentioned, you're entirely free to implement your own with the map merge policy interface, and you can configure that then to the replication. So WAN replication, it's production proven. It's being used at major investment banks, and it's also being used in many open source deployments. The configuration, again, as I said, it's XML, or you can configure it programmatically. Here's an example of some XML configuration, and here you can see that we have this WAN replication called my WAN cluster, and this replication scheme is going to replicate to US and to EU West. So these are actually two Amazon EC2. If you know Amazon EC2, you recognise these, but these are two Amazon EC2 locations. You can see here's the replication implementation we're using, which is the out-of-the-box WAN no delay replication, but you're entirely at liberty to implement your own if you wish. And here are the endpoints where these are the receiving sockets on the other side where it's going to receive the replication. And we'll look at this in a bit more detail in a moment. So I want to just run for you a quick demo that I've got set up in Amazon Web Services. So this is a good way of showing you A, Hazelcast running within EC2, and B, actually showing you WAN replication. So what I have in this demonstration is I've got 3 different Amazon regions, so US East 1, which I believe is Virginia, EU West 1, which is Ireland, and AP Southeast 1, which is Singapore. And within each of those regions, I have an Amazon T1 micro instance, so I've got 2 of those within each region. And then within each one of those instances, I'm running one Hazelcast JVM in each. And those 2 Hazelcast JVMs are forming a cluster together. And then I have them configured to replicate their maps to the other regions. So anything I update in US East 1 will be replicated over to EU West 1 and AP Southeast 1. And similarly, if I update something in EU West 1, then that map entry will be replicated to US East 1 and AP Southeast 1. Okay. So let's look through that demo now. I've started up my instances and I've fired up my Hazelcast instances within them, and I have a project that I want to show you that shows you the configuration files. So you can see in this project I've got my configuration files for AP Southeast 1, EU West 1, and US East 1, and in each one you can see I've set up my WAN replication here, my endpoints. Let's just go into presentation mode. So here they are. So I've configured this. This is AP Southeast. So this is Singapore. So Singapore is replicating out to US and EU, and so it's called my WAN cluster. Okay, this replication name. So this is a reference. So you can have many of these within a being used by a single cluster. So I might have another one of these that replicates maybe only to another site or set of sites. And what you do is you take this reference name here, my WAN cluster, and you attribute that to any kind of map configurations that you have. So what I've done here is that I've just attached that replication scheme to the default map for the time being. So if we scroll down this default map, you can see I've set the WAN replication reference to my WAN cluster, and I've given it a merge policy as well. Okay, so if I was to explicitly define a map in here rather than just the default, I could have another map name here that would be storing particular information that I only want replicated, let's say, to some other site somewhere in the world or to somewhere off site. So you can see that there's a disconnect between the maps and the actual WAN replication. So you can mix and match those. So as I said, I've got those all up and running now, and I've also got a management console running. So I can show you all of the clusters running via the management console. Here we go. So in the management console, you can see here, if I do a drop down here, you can see I've got AP Southeast 1, I've got the 3 clusters effectively, and I can click via the management console, I can look at all of these clusters. So if I look at EU West 1, here's the EU West 1 machines, and here's this cars map that I've populated. So I've got a map with some car information within it. And you can see here, I've got 8 entries, okay? There's 8 entries within the cars in Europe. And if I were to go over to US East 1, and we look at cars in US East 1, there's my 8 entries again, okay? So what I want, and if we look at Singapore, we'll see the same. Well, what I want to do now is let's simulate Singapore going down, or there's some problem in the connection. So and then I'll save some records into the European cluster, and you'll see that the records get transmitted over to America, but obviously Singapore's not down. We'll bring Singapore back up line again, and we'll demonstrate the fact that these records have been queued up, and you should see that Singapore comes in line with the update as well. So I'll just move over to my terminal windows where I've got the Singapore servers running, and I'll terminate those. So let me just kill those guys. So if we do a kill, I'm just going to do a kill -9 on these. So that one's dead. Actually, I didn't run this one in the background, so if I just kill that, it should just kill it anyway. Yeah, that one's dead as well. So Asia is down now, but we've still got Europe and America running. So I'm going to move over now to a quick little project, which is effectively running as a Hazelcast client. And let me show you this. Okay, so we have this one class that I've written, and within this one class, I'm actually creating connections to all of the clusters. So you can see here, I've got Asia blanked out for the time being because I'm gonna, I don't want to write to that if it's down, but in here you can see I've got a connection to the US, so you can see I'm creating a client config object. I'm setting the addresses here, which is the Amazon address. I'm setting the name and the password for the cluster, and I'm actually just doing the Hazelcast client, new Hazelcast client connection with the US config, and I'm getting a Hazelcast instance. Okay, I'm just calling it US client, and from that I'm getting a reference to the cars map. Okay, and I'm calling it US cars map. I'm doing exactly the same with Europe, and I'm calling it EU car map. And now what I'm going to do is I'm going to create a key, a car key, and a new car, and I'm actually going to put it in the cluster. And then in this instance, I'm going to put it into the European cluster. Okay, and then I'm going to wait for 500 milliseconds. Replication goes through very, very quickly, but I'm just going to wait for a second, and then I'm going to try and get that same record out of the US car map because it should have replicated across at that point. So let's run that now, and let's see what we get. So if you recall, we were running with 8 records in the cluster. So let's run this now. You can see I've made my connections, and if we just scroll up through here, you can see there's the first, there's my first connection to Europe, and here's the other connection that I've made over to. That's America, and that's Europe, and I'm putting the car into the EU cluster, and I'm doing that map get, and there you go. There's that car that I placed over. It's already replicated over the WAN into America. So if we look at our map entries over here, and we'll come off of AP Southeast, obviously, because that's not being updated. It's down at the moment. And there you go, there's the 9 records now, it was 8. So there's the record that I added into Europe. And if we go to the US, there's the record there, and it's 9 now. So what I want to do now is I'll bring back up Asia now. We'll bring up the Singapore instances. We'll start that server. We'll start this guy as well. We'll run this in the background. What I'll do is I'll tell the no hut output, and then we'll be able to see it actually making connections. And here you can see it's accepting the socket connections from the other sites. You can see here's the Singapore cluster accepting the socket connection from Europe again, and here it is accepting the socket connection from America. Okay, so if we now go back to our management center, and I now look at AP Southeast 1, you see we're all up and running again. Here's the cars map, and there's those 9 records. So there you can see we didn't actually lose any data when we did that. And just to prove a point, if we were to make a connection now in our code over here, I just uncomment this here and here, and we can just do a, let's just get rid of that put because we don't need to do the put, but let's just do a get out of the, let's copy this. We'll see if we can get that car of Asia Pacific as well. Run that. There's made its connections to Asia Pacific, and there you go. There's the same car, and we've gotten that from the US cluster and the Singapore cluster, and there it is in there. Okay, so that's WAN replication. So the other thing we want to talk about, I'll just very briefly talk about C# clients. It's a whole topic in itself, looking through that. But let me just find the correct. So C# clients, they work, and their interface is exactly the same as the Java interface. Our C# clients, they're first-class API citizens. So anything that you would find in our Java client, then you should find in our C# clients. They're being used in production around the world. So as I said, they're first-class citizens. They have pretty much everything the Java client has within it. So you can have event listeners on the central cache. You can do near caching as well. Yeah, it has full locking capabilities against the cluster. So you can do optimistic locking. You can do pessimistic locking as well via the C# client. It also has full predicate query capability. And you have the ability to run distributed compute tasks into the cluster as well. So if you want to find out more, you can again go onto our documentation. The documentation has been there's a whole bunch of improvements on documentation, but if you go to where we talk about the clients, where is it? It's just down here. You'll see that there's a whole bunch of examples on .NET clients and how to use them. So how to use client configuration, how to use client, how to start up a client. So it's all in here, and you can see here are the objects that are supported. So you can see it's basically the entire set of objects we've spoken about, distributed structures that we've spoken about in our previous seminars. So they're all available to you via the .NET client. So last but not least, I wanted to take you through in the few minutes we have left on our roadmap and where we see things going in the rest of 2014 and early 2015 as well. Now, I'd just like to caveat that, of course, whenever we talk about roadmaps, things are subject to change, but as things stand today, this is as I said, what we think is going to happen in the future with Hazelcast. So through 2014, at a very high level, we're going to be firming up our in-memory data grid offering and providing extra functionality around that space. As we move through 2015, we're really going to become the features are going to be based around high-density caching, and then finally through 2016, we think that that's going to then evolve into more an operational data store set of applications and features. So version 3.3, which is being released shortly in the next week or so, that's already been released, and you can already go onto our website and look at the version 3.3 RC candidates, and you can look at the documentation for the updates that have occurred in now. But briefly, in 3.3, you'll find things like replicated map and some enhancements to our map reduce. They're some of the main features. But looking forward to 3.4, which is going to be coming out towards the last part of 2014. We're going to have continuous query caching. There's going to be enhanced. We're going to be enhancing our C++ and C# clients. We're going to take secondary indexes off heap, and there's going to be something called DIY partition groups. Now, DIY will be the ability to set up partition groups. You can actually define where certain backup partition groups are in your set of hardware or in your cluster. So if you imagine a scenario where you're spanning one cluster across two data centers, so these two data centers are very, very close together, but one of them is effectively a DR data center. But you want to run it in a warm configuration. So you want to make use of that DR hardware. You want it to be running as part of your day-to-day system. So you can do that. But what you would want to do is you don't want all of your primary updates being spread across when you create a cluster across two data centers. Ordinarily, in a normal configuration, Hazelcast treats those two data centers as one contiguous cluster, and you're going to have primary records on one side and spread across the two data centers, and you can have backups spread across the two data centers. So of course that gives you a problem if one of the data centers dies. So what we would allow you to do with DR where partition groups is that you can say that I want all of my primary entries to go in one partition group, which you define as a set of IP addresses within one data center, and then we would guarantee that all of the backups will go into the other partition group, again defined by IP addresses. So you can have all of the backups in one data center and all of your primaries in another data center, and then should you get a situation where one of them dies, then you've got a complete set of records in both data centers. Okay. There's going to be more off-heap data structure. So off-heap is a big thing for Hazelcast. It's something that we're investing heavily in. So already in our enterprise products, we have off-heap. So by off-heap, we mean the ability to store map entries outside of the JVM heap memory, and by doing so, then you can have very, very, very large amounts of storage that is referenced just by one JVM, and then obviously the benefits behind that are that you're not subject to huge garbage collection pauses. When you run JVMs that are above a certain size, 8, 9, 10, 7 gigabytes, depending on your use case, then you may become subject to garbage collection pauses, and this is something that we're trying to resolve with our off-heap implementation. So more data structures for off-heap. So by that we mean things like queues, sets, lists. Okay. And again, on the off-heap theme, there's going to be near caches in the Java client that are going to be actually off-heap. So the near you'll be able to reference on your client side memory outside of the heap to use as to be referenced by your near cache inside the Java client. Obviously, when you're running Java clients normally, the JVMs on those might be a bit smaller than normal, but you might want to reference all of the memory potentially available on that machine, or at least more of it than you normally would. And then JCache, we're going to be providing additional features around JCache, and that's going to be around mainly around off-heap implementations for JCache. And lastly, on 3.4, we have at Hazelcast now we have a new performance team, and that performance team, and also we have new employees that are working solely on documentation, and we'll be reaping the benefits of those guys in 3.4. So 3.5, a big thing for 3.5 really is restorability. So this is where the ability to take snapshots of a system or an entire cluster for quick startup, and also the ability to overflow as well. So overflowing things to disk. There's going to be an improved management center. So I've already demonstrated to you the management center, but there's going to be a whole host of new features in our management center. There's going to be an increased number of out-of-the-box application J2ee containers that we support explicitly. So you can have filter-based web session replication and clustering using filters, but we're writing vendor-specific versions of those as well for high performance. We're going to be looking at high-speed networking as well, so we're going to be looking into shared memory and RDMA networking, and again, more enhancements to on-heap and also to area querying as well, and again, just more general focus on operational store as well in 3.5. So, I think that's just about it. I'll hand over to Andrew to pick up questions, but it's been a pleasure talking to you all for these last 4 or 5 weeks. I hope you've gained something from these. As I said, they're very, very, very quick rundowns of the features of Hazelcast. We do have, obviously, training courses that we run that are 2 days that contain an awful lot more content and a lot more hands-on labs. So do please consider those. But if you'd like to get in contact with me personally, you can reach me at david@hazelcast.com, or you can follow my Twitter feed, and I'm at @dbrimley. So again, thank you very much, and I hope you get as much out of Hazelcast as I do as well. I'll hand over to you, Andrea.
How does Hazelcast split brain issue with deletes?
Right, so with split brains, again, that would be where you would be using the merge policies. So we covered split brain in an early webinar, but let me just take you through that. We effectively give you when maps have merge policies that you can configure. So if we look at the documentation, here we go. So we're talking about network partition and the split brain syndrome. So the way that you would handle that is we do handle that, and what effectively gets executed are the merge policies here. So when you define a map, you can define a merge policy here, and that merge policy, when we detect that two split parts of the network are coming back together again, there might be on one side of that split network, the map entry for key A has been updated, and on the other side of the network, key A has now been started to be updated as well. And Hazelcast will detect that those two are coming together again to form the cluster that they once were. And it's at that point that we, as it will detect that there's 2 entries that are colliding effectively, and it's at that point that Hazelcast calls the merge policy, and it gives you the 2 entries, okay, the 2 entry views. Now, an entry view is a wrapper around a map entry, effectively, and with an entry view, we give you extra statistics like timestamps and versions as well. And using those 2 entry views, then you can decide who the winner is. So you can just choose one or the other, or you can, if you decide, you can somehow perform some merging operation where you merge the properties of both of those entries if you wish to do so. So that's effectively how we handle it. But if you look at the documentation, you see we have a very extensive write-up of how network partitioning is handled and split brain syndrome is handled.
And that's specifically on deletes?
On deletes. So yes, you could. I mean, if you want to, but if by deletes you mean can you remove the entry, then yes, you can. You can remove the entry if you want to. So you can return a null out of the merge policy, and it will delete the entry.
Okay, thanks. Do we have any other questions? It looks like that might be it.
Okay. Well, as I said, thanks very much, everyone. And the slides and the actual webinar, I think, will be online, won't they, Andrea?
Yes, we'll post the recorded webinar on our website, along with the link to the code samples and the slides. So thanks, everyone.
Thanks, everyone. Bye-bye.